Hello everyone, welcome to In 5 Minutes. In this video we are going to see a sum that is based on Radix to DIF FFT algorithm. First we will solve a sum that is based on period of 4. So that is capital N is equal to 4. Let us have a look at the question. The question states that compute the DFT of the sequence that is x of n cos n pi by 2 where the period is 4. We have to use here DIF FFT algorithm. But let us find out the terms where n is ranging from n is equal to 0, 1, 2, 3, that is cos of 4. Now when n is equal to 0, x of 0 is equal to cos of 0, that is 1. When n is equal to 1, x of 1 is equal to cos of pi by 2, that is 0. When n is equal to 2, x of 2 is equal to cos of pi, that is minus 1. And n is equal to 3, that is x of 3 gives us cos of 3 pi by 2, that is 0. Now we can say that x of n is equivalent to 1, 0, minus 1, 0. So now we can plot the flow graph of 4-point DIF FFT. Here we have to also see the twiddle factor. The twiddle factor will be W4 raised to 0, that is e raised to 0, which again gives 1, and W4 raised to 1, that is e raised to minus j 2 pi by 4, as capital N is equal to 4, that will give us e raised to minus j pi by 2, and that is cos pi by 2 minus j sin pi by 2. Now cos pi by 2 is 0 and sin pi by 2 is 1, so it is 0 minus j, it gives us minus j. Now we will plot the graph and see the output of the first stage and then the final output. So now we will draw the flow graph. But here the flow graph will be in reverse order as compared to decimation in time. That is, at the input the sequence will be x of 0, x of 1, x of 2 and x of 3. But at the output it would be a bit reverse order. That is x of 0, x of 2, x of 1 and x of 3. Now the multiplying factors are also needed to be added. But here the multiplying factor, that is the twiddle factor, comes after the summation sign. So let us see that. Let us draw the flow graph. That would be like this. Also we have to mark the directions of the flow. And as the butterfly ends, there is a minus 1 as multiplying factor. The outputs of the stage 1 can be named as S0, S1, S2, S3. Now at the second stage, that will give us the finest output, we would mark them as directly x0, x2, x1 and x3. Now we also mark the directions. Here we can see that the minus 1 factor lies here, and also W4 raised to 0, that is the twiddle factor, will lie here. Now let us solve this sum. First, the output of the first stage will be, that is S0, having input from x of 0 and x of 2. Now we will write the equation as S0, that is the output of the first stage, is equivalent to x0 plus x of 2. That will give us 1 minus 1, that is 0. Now S1, that is having inputs from x of 1 and another input from x of 3. It will have x of 1 plus x of 3, which will give us 0 plus 0. Then the output is again 0. S2 has inputs from x of 0 minus x of 2. That is S2 having input from this side, that is x of 0 coming here, and another input x of 2. But because of the multiplying factor, it becomes minus of x of 2. So it is 1 plus 1, that is 1 minus of minus 1 will give us 2. S of 3 is equivalent of x of 1 minus x of 3. That would be 0. Now we'll get to the final output. Final output here, that is the x of 0, is having the first input from S0 and then S1. So it would be like x of 0 is S0 plus S1. Again both the values are 0, so it becomes 0. Similarly, x of 2 is equivalent to S0 minus S1 into W4 raised to 0. Again, both the values are 0, so it comes out to be 0. Similarly, x of 1 having input from S2 plus S3, that is 2 plus 0 will give us 2. And finally, x of 3, that is having input from S3 and S2, that is S2 minus W4 raised to 0 multiplied by S3. So like the multiplying factor is multiplied after the sum, so finally the output comes out to be 2. Thus we have found out the x of k, that is x of k, that is the DFT, is equivalent to 0, 2, 0, 2. So this is the 4-point DFT of the sequence using DIF FFT algorithm. Thank you.